Hi, AP Stats. Welcome to a hopefully very short video where we're going to start 6.3a. In this chapter so far, we've talked about different kinds of random variables and defined what a random variable is, a variable that takes a number, and we've looked at how we can combine and make new ones. But in this section, we're going to look at a very specific type, a binomial random variable. So on your notes sheet, you've got this first sentence. The count x of successes in a binomial setting is known as a binomial random variable. Well, that doesn't mean a whole lot. Let's look a little bit more. The probability distribution of this random variable x is known as a binomial distribution, and it has parameters n and p. We're going to stop there for just well, actually, I'm going to give you the whole definition and then I'll explain it. With parameters n and p, where n is the number of trials of this chance process, and p is the probability of a success on any one trial. The possible numbers of x are the whole numbers from 0 to n. If I were you, I would pause the video right now and write down this paragraph. A binomial random variable, as mentioned here, this is a definition, and we're going to come back to it. I promise. But in order to consider whether or not something is a binomial random variable, we're going to look at 4 different statements. Is it binary? Is it independent? Is there a set number? And is the success the same? So let's look through these 4 ideas, and then I'm going to get back to this definition and give you an example. Binary. You must be able to categorize the outcomes as either a success or a failure. Binary, it means one or the other. I guess I'm not really saying the correct definition of binary, but basically it's either A or it's B. It's a success or a failure. If you're in a computer programming class, you probably know a lot more about what it means to be binary. But for our definitions, we're going to specifically say success or failure. Second question, independence. Are trials independent? We know what it means to be independent, right? It does not influence the next trial. If both of those things are true, if the outcomes are either yes or no, success or failure, if the trials are independent, then the next thing we're going to check is the number of trials is fixed ahead of time. Is the number of trials fixed ahead of time? If it is, then we're good. That's a binomial random variable. It has a fixed number of trials. And then last but not least, this S for success. Is the probability of a success the same on every trial? The probability of a success is the same for every trial. These are the 4 characteristics that help us define a binomial random variable. Notice the book gives us an acronym, BINS. I don't know if it necessarily helps, but maybe it will. We need to remember our BINS to check for if something is a binomial random variable. Going back to this definition, let me give you an example. Let's let x be equal to the number of heads obtained, when I flip a coin, we'll say 4 times. So let's think about this. If I'm flipping a coin, I'm either going to get heads or I'm going to get tails. And if I flip a coin 4 times, I could get 4 heads, or I could get 3 heads, or 2, or 1, or none, right? I could get all tails, which would be 0 heads, 1, 2, 3, or 4, heads. This is a random variable. Let's consider, is it a binomial random variable? So the first question we would ask is it binary? Could we categorize the different outcomes of this event as a success or a failure? I would say, yes, it is binary. A success would be I get heads, and a tails would be a failure. Of course, we're not really failing when we get tail, but we can say it as like a yes or a no type thing. Next up, we ask, are the trials independent? And we would say definitely yes, right? We know that flipping a coin, each flip is independent of the next. Each trial, each time I flip the coin, is going to be independent. Next up, we have number. Is there a set number? In this case, yes. N, the set number in this trial, is equal to 4. I am flipping a coin 4 times, and that's all we're looking at. Those are the 4 trials. And then last but not least, S, is the probability of a success the same every time? Well, let's think. We said success was getting ahead, and if I consider the probability of getting ahead on any flip of a coin, it's always 1/2. So the probability of a success is the same every time. I have these 4 characteristics, bins, which means this random variable right here is known as a binomial random variable. It's a specific type. Now I want to go back for a second to the definition and just kind of tie it all together and make sure we're feeling okay. So the count x of successes in a binomial random, or excuse me, in a binomial setting is a binomial random variable. X is the number of heads. X is the number of successes where a success is a head. The probability distribution of x has the parameters n and p, where notice n is the number of trials. So in this case, we flipped a coin 4 times. And p is the probability of success on any one trial. So even though we have the probability of heads here, in the future, we're just going to write p is equal to 1/2, where p, again, is the probability of a success on any one trial. The possible values of this random variable will always start at 0, no successes, and go to the total number of trials. In this case, 4. That is our introduction to this section. When we come to class on Tuesday, we're going to go through the next example and then a couple other characteristics of binomial random variables. Have a really good weekend.